Picture a single high school auditorium, 1,200 people inside, teenagers on bleachers, parents along the walls, teachers near the exits. That's it. That's everyone. Not everyone in your town. Not everyone in your country. Everyone. On Earth. Every last human being that would ever live. Every person who would ever love, build, invent, or leave a mark on history, descended from a group small enough to fit in that room. And for over 100,000 years, that thread held by almost nothing. What nearly cut it? Ancient DNA just gave us the answer, and it's not what anyone expected. For decades, geneticists noticed something that didn't add up. Modern humans have spread to every continent, adapted to Arctic tundra and equatorial jungle, split into thousands of distinct cultures and languages. By every measure, we should be one of the most genetically diverse species on the planet. But we're not. When scientists compare human DNA from populations around the world, the differences are remarkably small. Smaller, in fact, than the genetic variation found among chimpanzees living in the same forest. Let that sit for a moment. A group of chimps in a single patch of African jungle carries more genetic diversity than the entire human species. To geneticists, this is a red flag. It's the fingerprint of catastrophe. When a population collapses to a tiny number of survivors, most genetic variation simply disappears with the dead. The survivors rebuild, but they can only pass down what they still carry. Generation after generation, that narrow gene pool becomes the foundation of everyone who follows. Scientists call this a genetic bottleneck, and for years, they thought they knew which disaster caused ours. They were wrong. For 30 years, the leading explanation was the Toba eruption. 74,000 years ago, a supervolcano in Sumatra detonated with a force 10,000 times greater than Mount St. Helens. Ash rained across continents. Early climate models predicted years of volcanic winter. The theory was elegant and dramatic. Toba killed nearly everyone, and the survivors became us. It dominated textbooks. It was cited in documentaries. It felt airtight. Then archaeologists started digging through the ash layers themselves. At sites across India and Sumatra, they found stone tools below the ash. They found stone tools above it too. Same designs, same techniques. No break in occupation, no sign of mass abandonment. If Toba had wiped out humanity, the archaeological record should have gone silent. Instead, it whispered quietly right through the eruption, continuous and undisturbed. Climate scientists ran more sophisticated models and found that the cooling from Toba, while severe locally, was unlikely to have triggered a global extinction event. And when geneticists mapped the bottleneck signal in human DNA more precisely, the dates simply did not match. The collapse encoded in our genes happened far, far earlier than 74,000 years ago. Toba didn't almost end us. Something much older did, something we hadn't been looking for. In 2023, a team led by geneticist Wang Zhu at the Chinese Academy of Sciences published a study that stopped the field cold. They weren't digging through ancient sediment. They were analyzing the genomes of over 3,000 living people drawn from populations across Africa, Asia, Europe, and the Americas. Using a computational method called FitCol, which reconstructs historical population sizes by tracking the patterns of genetic variation accumulated across thousands of generations. They searched for the true signature of collapse buried inside modern human DNA. They found it, and it was unlike anything previously documented. Approximately 930,000 years ago, the effective breeding population of our ancestors plummeted to just 1,280 individuals. Not a city, not a town, not even a village. 1,280 people. The collapse wiped out an estimated 98.7% of all human ancestors alive at that moment. And it didn't end quickly. The bottleneck persisted for roughly 117,000 years, longer than all of recorded human history. For over 100 millennia, every person born into that tiny population was one bad season away from ending the entire line. An estimated 65% of our species' genetic diversity vanished forever during those years. Traits, lineages, entire branches of potential human evolution gone without a trace. This wasn't a regional disaster. This was a near erasure of our entire species. So what caused it? The answer appears to lie in the climate, but not a single eruption. something slower, more relentless, and arguably more terrifying. Around 900,000 years ago, Earth's glacial cycles shifted. Ice ages, which had previously run on 41,000-year rhythms, began stretching to 100,000-year cycles. Ice sheets grew thicker. Carbon dioxide in the atmosphere dropped to some of the lowest levels in millions of years. The land dried. Across Africa and Eurasia, the lush grasslands that ancient humans depended on contracted into scrub and dust. Scientists call this transition the Mid-Pleistocene transition, and its fingerprints are written into the teeth of fossilized herbivores. Isotopic analysis shows a sudden collapse in grass eating. The animals that fed our ancestors were running out of food too. Without fire, and the evidence for controlled fire doesn't appear in the archaeological record until around 790,000 years ago, there was no reliable warmth, no way to cook tougher foods, no way to push further into hostile terrain. Our ancestors were already stretched thin. The climate tightened the trap. Species after species collapsed alongside them. Saber-toothed cats, ancient canids, entire lineages of sharks and marine mammals. The Mid-Pleistocene transition was a mass extinction event, and early humans were barely on the surviving side of it. Here's where it gets eerie. Paleoanthropologists had long noticed a strange silence in the fossil record. Between roughly 950,000 and 650,000 years ago, hominin bones essentially disappear. Sites that previously yielded regular finds go almost completely quiet. For years, this gap was unexplained, a frustrating hole in the story. The genetic bottleneck fills that hole perfectly. There are simply no fossils because there were almost no people. The archaeological silence is the shadow of a near extinction. And just at the edge of that gap, dated to approximately 773,000 years ago, a partial skull emerged from a quarry near Casablanca, Morocco, the Thomas Quarry skull. Its thick vault and heavy brow ridge mark it as early Homo heidelbergensis, the species now understood to be the last common ancestor of Neanderthals, Denisovans, and modern humans. It appears precisely when the genetic evidence suggests our ancestors began, slowly, painfully, to recover. A single skull from the moment the thread held. The alignment between what the DNA predicts and what the fossils show is not coincidence. It is evidence. Science doesn't settle quietly, and this finding is no exception. In 2025, a team led by researcher John Terhorst published a direct challenge to the FitCol results. Using the same genetic data but different analytical methods, they found no bottleneck as sharp or as ancient as the 2023 study described. Their argument: FitCol may be misreading complex ancient population structures, migrations, isolated groups, partial mixing, as a single catastrophic collapse. Other researchers have proposed that modern humans may descend not from one tiny surviving population, but from two or more ancestral groups that later merged. The bottleneck may have been real, but the picture may be more complicated than 1,280 people in a single location. What no one disputes is this: something extraordinary happened to humanity around 900,000 years ago. The genetic signal is too consistent, the fossil gap too precise, the mass extinctions too widespread. The exact mechanism remains contested. The scale of what was lost does not. Every person alive today, 8 billion of us, traces back through an impossibly narrow passage in time. A group smaller than a high school auditorium held the entire future of our species in a world that was actively trying to kill them. For over 100,000 years, they survived. We don't know their names, we don't know their faces, but we carry their scars in our DNA. The question worth sitting with isn't just how they survived, it's what we would have lost if they hadn't. What branches of human potential died in those 117,000 years? What voices never got to speak? We'll never know. But we exist because someone, somewhere, endured long enough to pass the thread forward. If this kind of mystery is what keeps you up at night, you're in the right place. Subscribe to History Diary and hit the bell. Every week, Ancient DNA hands us another cold case, and we open it together.